So I'd like to welcome everyone to the 2017 Finger Lakes Chapter of INCOSE Annual Dinner Meeting. We have these meetings every year. We bounce back and forth between universities. Last year we had it at Syracuse, 2 years ago we were here at Cornell. Before that we were at RIT and U of R in Rochester. Okay, this is a roundtable discussion. We'll have a set of panelists up here from both academia and from the workplace, so that you can ask as many questions as you like as to what it's like to be a systems engineer, or any information you want to know about systems engineering in general. We're going to go through a very brief, it's going to be very brief now because I'm late, presentation to tell you a little bit about INCOSE in general, system engineering in general, the Finger Lakes chapter, things of that nature, so that you can see what it's like in the systems engineering world and help you stimulate questions for the panel and any questions you may have. The agenda is, what is systems engineering? What is INCOSE? Finger Lakes chapter of INCOSE, the membership benefits of INCOSE, membership types, and then we'll finish with our roundtable discussion. So what is systems engineering? All right, there's many definitions for systems engineering across the different types of standards, professional standards that go on with all the volunteer organizations that manage these standards. And it's very difficult to come up with one that sums them all up. But I like this one. SE is a methodology that can be applied to any process, formal or informal, and to improve efficiency and the likelihood of success. That to me is really system engineering in a nutshell. Okay, we'll talk. There's the basics of systems engineering are stakeholder requirements, system requirements, high-level architecture design, design specifications, and validation and verification. So the stakeholder requirements are very important so that you capture the needs of the customer. Okay, the what, basically, what they want, not how they want it. Once you get down into the lower level requirements, below the line between the problem domain and the solution domain, you get into system requirements, and that describes how you're going to give the customer what he wants. But through all this, you need to have tight communication with the customer, because what he wants at the beginning of the project may not be what he wants at the end of the project. So that's why we have validation, we have gated reviews, we have technical interchange meetings, we have very good communication with the customer. And then when we finally get the system specification written and it's what he's pretty much locked into what he wants, then we can design the system and verify that the system meets the system requirements. And of course then there's another round of validation with the customer to make sure it's what he wants. Okay, everybody should have seen the Systems Engineering Handbook that was passed around. So this is one of the many products that INCOSE offers its members for free. Okay, there's also a guide to writing requirements. I actually was a co-author on that from the requirements working group. That's also available. And that one you can't buy if you're not a member. You have to, like this book you can buy if you're a member, you can get it bound. But if but you can't get the guide to writing requirements. It's not available for public sale yet. So there are key benefits to becoming a member. Okay, so the Engineering Handbook talks strongly about some of the things we just talked about, and these are the engineering principles, the system engineering principles that we use to properly manage a project. And I'm sorry if I'm rushing here, but I'm just a little bit late on time. So, what the system engineering principles help you do is to define the system up front, get the needs from the customer, find out what he actually wants. Sometimes he might not know what he wants, and it's your job to get it out of him. Okay, and I developed this thing called tell them what they want, right? So if you tell them what they want and they don't like it, they're going to tell you what they finally want, right? If they like what you want, what you're telling them, then you win too. So you can't lose. You just tell them what they want. Don't be afraid, because believe me, when they don't like something, they know how to tear it apart, right? But if you ask them just to think in the abstract, they can't do it. Well, some of them can't do it. I talked about the problem domain and the solution domain. That is the what and the how. Your high-level design is your architecture. You come up with platforms for different domains depending on your system architecture. And then you do your you do system requirements reviews, preliminary design reviews, so that the customer can sit in and say, take what you've already done and validate that's what he wants. Okay? And you could do exactly what he said, and it still might not be what he wants. So that's a very important thing to note. And it's also good not to just spring it on him during the review, but to have, weekly or bi-weekly interchange meetings with the customer so that he sees where you're going. Hiding stuff from him is not a generally good idea, in my opinion. Okay, so that's the validation. And then your low-level design is where you get into schematics and software coding and things of that nature. By that time, it should be just a simple execution. If you do the systems engineering right up front, you've answered all the tough questions, then it's just a matter of executing. Should be very easy to do. Because part of the system engineering process is to capture, when you write a requirement, the most important thing about that is to say, how am I going to verify this requirement? Because if you don't write the requirement where it's easy to verify, or there's some kind of a method to verify it, then when you go to sell it off, how do you prove it? How do you prove that you meet that requirement? So the best place to do that is when you're writing the requirement, or if you're seeing other requirements people have written, ask them, how am I going to verify this? And then they'll have to change the requirement such that they can be verified with either analysis, inspection, demonstration, or test. Those are the 4 generally accepted methods. And they could be multiple too. You might have to do more than one verification method to verify a requirement. Okay, and then we have other validations such as critical design review. That's where before you start building metalwork, you're proving all the drawings. And before you start actually doing the design build, right, you go through this critical design review to make sure everything's in order before a lot of money's wasted on building prototypes and things of that nature. And then once it's all done, then you do a verification of all the system specifications by using one of those methods I mentioned earlier, analysis, inspection, demonstration, and test. Okay? Now, to manage your requirements, you have different tiers or levels of requirements documents. So the upper level, we call the parent documents, could be a statement of needs. No, it's not somebody's son. Okay? It could be use cases and various other, like statement of objectives, things of that nature. And what you normally do is you boil all those requirements down into one stakeholder requirements document. So at this junction here, that's the line, the main line. I mean, there's lots of little lines as you go down. But the main line in the project is that the line between the problem domain and the solution domain. Okay, so once you get into a system specification, you have to derive from the stakeholders' requirements what's needed to design your system. This is where every vendor, like if you have multiple vendors bidding on a job, then they have to come up with their own system specification that meets these requirements, and then they compete against the others. So their strengths and weaknesses are going to be different from others, and so this gives the customer, a good competitive thing competitive program, and they can pick the best one that fits their needs. Okay, and then to get from one level to the other, you have this little layer of analysis. I don't know how well you can see it on the screen, but there's these little blue blocks of analyses. Okay, and what we call that. So if you think of the tiers as a slice of bread, and you think of the analysis as meat, okay, or peanut butter or whatever, then you have what we call the system engineering sandwich. Okay, and that means that in order to get from one level to another, you have to analyze what the customer wants and figure out, with your strengths, how you're going to get there, okay? And so that's how we do it from one level to the other. We have to do analyses, okay? And then once you get the system spec, you have to go down into the subsystems, and there could be various subsystems. Just for an example, like airborne maritime fixed proposal I worked on, there were 3 basic domains, airborne, maritime, and fixed. So we had 3 basically system specs on their own, but for each domain. And then within each domain, you've got hardware components and software components. You've got maybe a power amplifier, maybe you've got a radio, maybe you've got an antenna system. So those are all requirements documents all on their own. And they all come from the upper level document. They're all allocated down from that document to other subsystems, and they're linked. So that if the customer comes up here 6 months into the project and says, I want to change one of these needs, we just found out something that's very important and we need to change it, you can turn on those links in your requirements database, such as doors or things like that, and it would track it all the way down so that when you need to estimate for the customer how much it's going to cost, you'll know exactly what needs to change, and it's much easier to estimate. So it's all done, systematically and methodically. And this is called a schema, so that you understand how that your family requirements relate to each other. Now this is the system engineering V. What this means is, okay, so your level of SE involvement is on this axis, on the vertical axis. On the horizontal axis is time, or time according to the project being progressing. Okay, so what this V tells us is that at first, system engineering is involved at the highest level, and as you go through the process of developing system requirements and doing your functional analysis, doing your design integration, the system engineering process or the involvement wanes. But once you get to the point where you're actually constructing the project and building it, then the system engineering involvement starts to wax or increase, so that you are more and more involved. And some of these might be iterative sections too, so you can see some feedback loops in here. Okay. Now, this particular type of drawing was taken from Systems Engineering Management from Blanchard, the 3rd edition, which is where they also, I believe, coined the phrase of a system engineering sandwich, or that might have been a requirements book. So now we talked about system engineering, now what is INCOSE? INCOSE is the International Council on Systems Engineering. So what INCOSE does is tries to drive the state of the art of systems engineering, and it works with people from all over the world. And I have colleagues in Australia and all over Europe, in Singapore. I mean, you name it. We have people that we see on a periodic basis at these international workshops we hold once a year. People come from all over the world to sit with their working group or a number of working groups, and they figure out what they're going to do for the year, and they come up with a plan. And and it's a strictly volunteer organization. You pay a small fee to be a member, and then you have access to all the products that are being made through these working groups. And there's also a local chapter that gets fundings, like us, like the Finger Lakes chapter, so that we can come here and try to teach you about systems engineering, teach you about INCOSE, and offer a few scholarships. Which, by the way, stick around because you have to be present to win it. So we'll raffle off three scholarships at the end. Okay. So where was I? INCOSE goals to advance the profession. Okay. Then we have an organizational structure of the board of directors, a corporate advisory board called the CAB. All right. This is probably not really too important for you right now, but if you have any questions about it, please come see me afterwards. So the corporate advisory board, say the company I work for wanted to be on the board. Okay, so they would pay a particular fee, and then they, that's pretty steep up front, and they pay a smaller fee every year. It gives them 2 free memberships so they can go and represent the company. And then everybody in that division, whatever company it is, whatever the division they are, has access to all these materials from INCOSE. That's the nice thing about it. They don't have full membership, but they do have access to the materials. And then there's a technical operation that controls all the working groups and helps them get organized, gives them what resources they need, like this GlobalMeet thing that I'm on right now. So even though nobody else is dialing into the meeting, I use this so that we can record it. And Jake is also recording it with video, so he merges the two together and comes up with a real nice thing. We did this a couple years ago. It's on the website. So I've told you about the working groups. There's approximately 40 of them. There's sector directors. There's also certifications. Okay, so an associate certification is if you're not a graduate yet, you can apply for and take the test, and the test basically is based on everything that's in this handbook. So you just learn the basic principles of systems engineering, and you should be able to pass the test. That makes you a systems engineering professional. You can, once you're out of school, you can apply for a CSEP, okay, which is a certified system engineering professional. And once you've been in the field for, I believe it's 25 years, you can apply for an expert system engineering professional. Okay, so now just a little bit about the Finger Lakes chapter. You can see we cover the western half of New York State, and we have people in Buffalo, like myself in Rochester, people in Syracuse, in Cornell, Ithaca, Binghamton, all over the place. So we hold monthly meetings, except for July, August, and December. We'll have a monthly meeting. It's usually the third Thursday of every month. You're welcome to dial in. Even non-members can dial in. We have an associates database list that we maintain, and we send out the notices to everybody. So if there's an interest in system engineering but not an interest in INCOSE, we welcome them, hoping someday that they would join. Okay. So we currently have 53 members. I really was going to check that figure, but I never really got to it, but it's approximately that much. And at least 4 of our people within the chapter have their certified system engineering professional certification. And the one student division that we do have is here at Cornell. Be nice to get one at Syracuse, hint, hint. All right. So, so the Cornell student chapter will be to, actually, Wes, could you talk to this a little bit for the Cornell student chapter agenda? Because this might be different from last year.
Well, as far as our agenda for this year, we've already met once on Thursday. We're in the process of electing a student board at Cornell. And I'm encouraging the Syracuse folks maybe to join us somehow, maybe even share a Facebook page. But one of the things we've stood up to share information is a Facebook Cornell INCOSE chapter group, we call it.
Mm-hmm.
That's why we can exchange information easily. And we're thinking about a project to do. That's one of the requirements that INCOSE has actually as a student chapter, is have some kind of an engineering related project. It doesn't have to be launching a missile to the moon or anything, but so we're...
How would you want to blow up the moon?
Yeah. I don't know, Dani likes missiles. Anyway, so we're spending this next couple weeks getting organized, and we'll be setting up an agenda and a schedule. And the plan is that we'll do a presentation at the end of the year, next May, for our FOC chapter.
Excellent, thank you. And for those of you who don't know, Wes Hewitt works here at Cornell. He teaches.
I'm a TA for the system engineering department, and also I teach SysML.
And he's also the treasurer on the board of our directors for INCOSE Finger Lakes chapter as well. Okay, so what are the memberships? What are the benefits for membership? All right, so you can see some of the INCOSE products over here. You leverage the INCOSE products, including the handbook, the guide to writing requirements, the measurement primer, many more. There's an Insight. It's a publication called Insight. They publish it quarterly. It's kind of like a magazine format that you get electronically. Access current and past issues in the System Engineering Journal. There's also a database of publications that you can search through. Gain exclusive access to INCOSE Connect. So INCOSE Connect is where it tells you where to go on the Wiley publishing page to download most of the products that we make. It also gives you access to all the working groups, okay, and you could probably request access to local chapters as well. You can, my favorite thing is collaborating with experts all over the world, right? And if you have a problem, you can reach out to them. There's forms you can use, or you can just use email. And then, so if you have a problem, did anybody ever run across this? Can you help me solve it? And, you get several answers back. So it's a nice community. Okay. There's also a body of knowledge that's very good. And what the handbook does is it helps guide you to use the standards that INCOSE has brought together to try and be consistent with each other, like 15288 and things of that nature. IEC, ISO IEC 15288. So where those standards are written for people in the know, the handbook really helps you use those standards more practically than just giving you a bunch of requirements. So I just listed a few of the events that are going on in October. In fact, I was talking about this with somebody earlier. The annual Great Lakes Regional Conference is going on. They ask us every year, because we're part of the region, as INCOSE is broken up into regions and then, sectors. So there's like 3 main sectors of INCOSE. There's the Americas sector, European, and then there's probably
Asia.
an what is it?
I think it's Asia. and
Asia or
Australia.
APAC or something like that. So we're in the Americas sector, and then the sectors are broken up into regions and then into chapters, right? So they ask us to help with that. And if you want to gain experience managing a project and doing work with a collaborative team over a long distance, it's, become a member, part of our chapter. We'll send out an email to say if you want to get involved, and then you can volunteer, and it's really good experience to do this type of thing. And you get exposed to a lot of people all over the world, right, that are very high up in very good at what they do. So I'd highly encourage to join just from that standpoint, so you can get in on some of these local things and lend a hand to try and help pull it off. Okay, then we have, if you're going to be in the UK, there's their annual system conference on the 21st, 22nd of November. And then the international workshop, which I've mentioned, it's always in either late January, early February timeframe. It's usually somewhere in the United States. In fact, it's always somewhere in the United States. This year it's in Jacksonville. The last 4 or 5 years it's been in Torrance, California, which is great because we love going there for personal reasons. Then the symposium. So the 2 major events are the IW, the International Workshop, and the IS, the International Symposium. They occur about 6 months apart from each other. And the symposium usually rotates internationally and then domestically here in the United States. Like this year, it was in Australia, Adelaide, Australia. I think the year before was Seattle?
Edinburgh.
Oh, that's
Scotland.
right. They had two in a row internationally because they were going to have it in Korea once, and something happened and they couldn't have it, so they moved it. So they had 2 years in the States, and now they have 2 years out. Okay, and then this year it's going to be in Washington, D.C. And like I said, you can collaborate with system engineering practitioners around the world, get a lot of great ideas, or you can help somebody with your great ideas. So there's 4 basic memberships. There's regular, senior, student, and developing country memberships. Okay? So the regular membership's $145 a year. All right? And that, there's really not much to say about it other than gives you access to everything that INCOSE has to offer. The senior membership is $80 a year. There's some stringent rules you have to follow to keep the senior membership going, but they do give you a break. And what you're interested in is a student membership is $38 a year, okay? And there are some requirements you need to meet as to guarantee your student membership status. I'll leave that up there just for a minute so you can read through it if you're interested. And it's on the INCOSE site. If you go to the INCOSE.org and look for membership, you'll be able to find these exact words up there as well.
It's hidden at the very top in small text. You got to scroll you got to look for it actually.
Yeah. But if you have trouble finding it, you all have my email address. Just let me know. I'll send you a link. Okay, then they have a developing country membership, which is about $53 a year. And so there's requirements on what you have to do to be from a developing country. Now I want to get to the roundtable discussion finally. Okay, and the theme this year is working as a system engineer. Now that probably sounds funny to most people, but there's a thing about systems engineering is it applies to anything that you do. You make a shopping list, those are requirements. Okay, you build a house. You tell the builder what kind of rooms, how many rooms you want, where you want the rooms located. Okay, so you're telling them what you want. Then they come back with an architect's specification. So they've derived the specifications from what you wanted, and you have to validate those. Okay, and make sure that they didn't misunderstand you or that you changed your mind and wanted to change that. So everything you do in life can really be traced back to system engineering. So you don't need to be a system engineer to practice systems engineering, but if you had formal training in the system engineering principles, it would make things you do go a lot easier. okay, and with a lot higher rate of success. But when you work as a systems engineer, you are basically managing projects and guiding people to use the system engineering principles so that it helps them get their things done on time, on budget, and with more organization. And the reason system engineering, formal systems engineering, the reason it became a thing is that the Air Force got sick of paying $1 billion to a company that never produced anything for them. And they just kept, well, we need more money. Well, we need more money. Well, we need more money. So they came out with these system engineering principles so that they're forcing companies to use this when they have government contracts. And my goal, and probably several others, is to try and get not only government companies to use it, but to get all companies to use it. And like anything else, you can tailor it such that you can do it as much as you need to, right? As much as you can afford. So with that, we've gone through this to try and stimulate questions for you. We have 2 panelists here from academia, 2 panelists from the workplace. We'll talk about SysML and modeling if you need to. We can talk about INCOSE if you have any questions, any general system engineering or anything else in general that you want to talk about. So our first panelist is Mary Driver from Lockheed Martin, Rotary and Mission Systems, System Engineering Project Manager is her title. Ms. Driver is a System Engineering Project Manager for Lockheed Martin, Rotary and Mission Systems of Owego, New York, for the ModelBased Engineering RMS business initiative and responsible for defining the MBE strategy for the engineering workforce on model-based practices, tool, process, and program implementation. Ms. Driver is a graduate of Binghamton University with a Master of Science in Electrical Engineering. She has been a system engineer in various roles for the past 15 years at Lockheed Martin. Isn't it lovely hearing about yourself? The next panelist is Kevin Devaney. He's our local chapter president, and he works at SRC Incorporated in Syracuse, and he's a systems engineering manager. And Kevin has 29. Pardon?
You don't have to read all of it.
Well, anyway, he actually does a lot of publications and he gives a lot of talks at the INCOSE symposiums. And he's been a real tremendous addition to our board. We can't thank him enough for joining these last few years. So he's one of the panelists tonight. And so those are the 2 from the working industry. And then probably a lot of you know Dr. Daniel Savea. He was here 2 years ago at our panel, and he's in the mechanical and aerospace engineering, but he also has an interest in systems engineering. And then we have Al George, who most of you at Cornell are going to be familiar with, who he told me earlier has actually started the system engineering department here, and he is going to be one of the 2 academia panelists. So without any further ado, I am going to bring them up to the roundtable for discussion. The format will be that you will ask a question, okay? And I will choose, if you're raising hands, whatever. And then I'll ask one of the panelists to answer the question, and then I'll ask if any other panelists have anything that they'd like to add, okay? And if you'd like to ask a particular panelist, just let me know you'd like to ask one of the particular panelists, and we'll go with that, okay? And so without wasting any more time, let's get to it. I'll have the panelists come up here. And if you can speak up, I'm on speaker here, so if you can speak up or get up and move to the front to ask your question, that would be really helpful. Thank you. We're going to ask the panelists to give us a brief history of a few items, like how they got their job, what they do on their job, things of that nature. Okay, so these are the 3 things. If you can start, Al, and talk about that just briefly, and you go down the line, and hopefully that will stimulate some more questions for you.
So when I got my undergraduate and graduate degrees, there really wasn't hardly any systems engineering anywhere, and I got into it by needing it and doing it, and I went from working in aerospace to aerospace and mechanical, and finally systems, by being exposed to various companies that were trying to do things like this, and I became more aware of what was going on as Rick mentioned, Air Force and military related things, though I was usually involved with more commercial companies doing this. And so let's see, advice on how to get a job in industry, I would just say there's different kinds of jobs, different things you can do, from a title that has nothing to do with systems engineering, but applying it and using it will advance you in the company much more rapidly than somebody who's very focused on particular things, although you need those people too. And how to be successful in your career, I could go on about that, but let me just, some of it's obvious and some of it takes too long to explain.
Okay. Can I ask you guys a question? How many of you are in undergraduate programs currently? So everybody's in master's and above level? Okay. Variety of backgrounds, I'm assuming engineering or other? Yeah, okay, all right. So the reason why I asked that question is that I have my master's in electrical engineering, had a bachelor's in math, so engineering was kind of an interesting path out of that. So when I started my job and I was given the title of systems engineer, I had no idea what it was. And the reason I got my job, I just got really lucky, and my professor/advisor happened to previously work at Lockheed, and he knew the person to call. So I got lucky, got the in, and I'll say it was all, on my amazing interview skills. But here I am now. I've got this job as a systems engineer. I have no idea what that means, and it almost didn't really matter, because once you start your job, you really get a lot of hand holding, and they guide you through what you need to do in your first couple of weeks to months to year in learning what your job's all about. And what I learned from that, you learn all the foundations in engineering, and you really figure out what does it mean to do all of these practices, and then it's all about how you apply those and applying them in a smart way. So my job as a systems engineer was great. I already have the foundations of understanding the technical bits about whatever the product was at the time, and now it's putting it in a logical fashion, being able to communicate that. And I think that's one of the things that I've really found the most interesting about systems engineering is the communication part of it, is knowing how to write, knowing how to speak to people, and how to translate somebody's ideas. I think Rick was talking earlier about customers not knowing what they want, and it's not just how your customers knowing what they want, but it's the whole team of engineers that you're working with as well, and being able to communicate what the design is, how it should work, what it means, and then when somebody develops that, being able to say, does that really make sense? So that communication aspect of it. I have moved in my career in various different roles. I actually got into systems management early on because of the people aspect of things, and really gravitated towards helping my teams with that communication, understanding the right process, the right tools for how to do all of that. So I will pass on to Rick.
Hi everybody, Dani South. I think a lot of you know me, and I probably introduced myself to a lot of you like last week, so it might be repetitive. But so, who here is from Syracuse? Just okay. Thanks for coming all the way, an hour and 15 minutes of driving. So I guess the first question is how I got my job or something like that. Share their career path. So again, it'll be repetitive for some of you, but so I think I got into systems engineering out of not really knowing what I wanted to do. And I feel like I wanted to say that because I feel like a lot of people get into systems engineering from that perspective, in the sense of, I like everything, I can decide. It seems like systems engineering, you do a little bit of everything, so I'm going to do systems engineering kind of thing. Of course, it really took me a long time to get there, and it was not really, a decision that I made proactively when I was in college or anything like that. But so, my background originally was in something called telecommunications engineering. So that really doesn't exist here, but it's sort of like electrical engineering with an emphasis in communications, RF technologies, and things like that. But then I also wanted to do space and airplanes, so I did another degree in aerospace engineering. And I also wanted to go to another country, so I went to France to do that. And then I was hired by this company that's called Ariane Space, which operates the Ariane 5 rocket. I don't know if you guys know what Ariane 5 is, but at the time, it's no longer true, but at the time, it was really the only rocket available to European missions. So all European satellites government satellites at least, were launched out of Ariane 5 rockets, and that was in Kourou in French Guiana. So that's pretty much on the equator, Amazonian rainforest kind of weather, mosquitoes and stuff like that. So I was there for 4 years working in operations with the Ariane 5 rocket, guidance, navigation and control, avionics, a little bit of everything. And then I decided that I was bored again and that I wanted to do a PhD, then I wanted to come to the US, and then I wanted to do early design work because operations is too late. I wanted to do some more early conceptual work, and I did my PhD at MIT in space systems design and architecture. So I went all the way from operations to the very beginning, right, which is the architectural design. And then I guess I came here because Al hired me, among other people. And I studied a course in systems architecture, and I also teach a class in satellite mission design. So that's my path. How to get a job in industry? Boy, I have no idea. I think one of the things that I thought was interesting on your presentation, Rick, was the certification. I'm obviously not in industry anymore, so I don't know. But I put myself in the feet of hiring managers, and if I have 1,000 CVs of people who just graduated with an MEng in systems engineering, and a few of them have a certification, I feel like that could be something that
It's a worthwhile investment.
Yeah, and it's not too expensive, right? To take
No,
that
it's not
test.
too bad.
Yeah. So I feel like, talking about something concrete that you guys could do to improve your chances, I feel like that could be something interesting.
And, we could basically try to, in the chapter, offer classes to teach the system engineering handbook so that if people wanted to, if a group of people wanted to do the certification, take the test, they could participate in these classes and then they can take the test on their own. If they go, what they're starting to do now is offer the exam for free to students if they go to one of the symposiums or one of the workshops. So there's always more about that, and it's dynamic, it's changing. So yeah, that would be a great recommendation.
Advice on how to be successful in their career. That I have no idea, so I'm just going to pass. And I'll let you, Kevin,
very good.
take that one.
So, we'll get to that later. I guess my path, I came to system engineering from software, so I did about 10 years in software development. And if you sort of know the history of software and systems engineering, there was a big push in the 80s to impose process on software. The CM, if you're familiar with CMM, the capability maturity model. So software kind of came first when it came to imposing a lot of rigor and process. So I had that experience, and I was interested in moving to systems, and I did that about 10 years ago, and that's when I started getting involved with INCOSE. The one thing about my company, I work for SRC, which is like a radar and electronic warfare company, and you'll see a lot of the INCOSE started with defense and aerospace, a lot of that, and like Rick said, the government imposed a lot of this rigor and process on the defense industry. I will say my company is kind of small, and so most of your system engineers start out as kind of doing systems analysis. And so a lot of you probably have MATLAB skills, I'm hoping. And so, when we interview people for systems engineering, we want to know, can you do stuff with MATLAB? Are you familiar with skills writing Python scripts? Because initially they usually start out by analyzing how's the radar working, and trying to learn the radar or learn how radar engineering is done, kind of by getting in the data and trying to figure out this algorithm doesn't work, or I need to improve this. And so it's really the more senior people that then get to design radars later on, and then those are the people that have to worry about the whole system engineering process and so forth. So I'll say, the people at my company do both systems analysis and systems engineering. And that's one way to look at it. As far as getting a job, let me say I agree with Dani. I think you should think about, if you have time, to to get the system engineering certification, because I think it certainly depends on the industry, but I think it does make you kind of stand out. And it does, I'll say that's a piece that also, you have the certification. If I knew you had the certification, I knew you would be familiar with the system engineering process. I'll say, a lot of times people from academia, they've really only done toy projects, right? And so a lot of them, you're only used to doing like a couple of week software project or a couple of week engineering project. You're not used to something that takes a year or two where there's a lot more rigor, a lot more documentation needed to execute the project. So I think that kind of gives some evidence of at least understanding of what a mature process looks like, whether you actually executed it. I know Wes was saying he's going to try to do a group project with the student chapter. So that would help as well.
I'll piggyback on
Yeah.
what Kevin just said there as well. As a hiring manager, I mean, I interview a lot of just out of college graduates, and one of the things that I look for is your experience, and it's generally through the hands-on aspect. So if you can tell me a story, if you can communicate to me, it gets back to that communication thing, on what you've done and how you've done it, and an understanding of parts of that life cycle, how you worked with the team, how all of those parts kind of integrate together. Your project can be internship-based, which is ideal. I know that gets harder as you're getting into your master's if you have or haven't had them as well. But then if you've had those project experiences, I'll even lean on if you had a senior design or your thesis project, something that you've had to do for an extended period of time that show you understand from the start to the finish of how something's got to work.
And also how to work as a team.
Right, that is huge.
Which is
Yep.
what systems engineering does. It makes working as a team a lot easier, because if you work by yourself, you're working in a vacuum. But if you have to work as a team, and you have to know what everybody else is doing so that you're going to be compatible with their inputs and outputs. And to answer the question about how to be successful, my experience has been to become a subject matter expert in something. Find one thing that you like to do and do it well, and throw your passion into it. Okay, that'll make you stand up. Like the level, the higher level engineers at my company are those people. They understand a particular piece of the technology that goes into making networking radios better than anybody else, and they're the people we go to sign off the requirements. Okay, for me, I specialize in system engineering, and so that's kind of where it helped me get to where I am as well.
One way to approach like an engineering career is to try to figure out, if you can, what what industry you want to go into. Do you want to go into defense? Do you want to go into communications? Do you want to go into power? And sort of like Rick was saying, is try to learn as much as you can about that domain as well. And maybe there's societies that are related to that you can get involved in as well. Because I think if you came in an interview with me, I'd want you to know what's going on in the defense community. I'd want you to know at least a little bit about radar. So I think that would also give you a leg up. If you know what industry you want to work in, you do a little bit of your homework. I hope this one is obvious. If you go, before you go interview with a company, go on their website and figure out as much as you can about their company. Very frustrating to me, somebody comes in and says, tell me what SRC does, right? Well, why are you here if you don't know what we do, right? So things like that. One thing what Dani said is an important interview thing, is be ready to tell stories. Tell stories about this project that you were on and the team wasn't working well and you helped fix it, right? Or tell stories about things that make you look good, right? Be ready to tell stories. Don't just have one-word answers, right?
Be ready to draw diagrams. We have a question.
Yeah, actually. So I think that's a question that mostly applies to the panelists working in the corporate sector. But really on a day-to-day basis, what kinds of individuals do you see yourself collaborating with the most? And obviously considering that the systems engineering and the implementation of a project is certainly a path that takes place over time and sometimes takes several years to complete. which makes me think that there's definitely other people you will have to interact with over time. But what would you say in the hierarchical structure of a corporate institution? What are the people that you usually interact with the most?
Mary, you want to handle it?
Go.
Sure. So it's a big and wide answer for a company like a Lockheed Martin. Even in my facility, we do so many different things, from building the product from scratch, right? I have hardware developers that do FPGA design and build a card, and that card goes into a box, and that box goes into an aircraft. And so there's so many multiple layers that it somewhat depends, again, on the product that you're focused on. From the systems engineering perspective, what I tend to see is your systems engineers work closely with your program managers, those who are responsible for the overall program, managing the work scope and being that interface with the customer. Sometimes they like to be in the middle. They don't really want you interfacing with them. And then the next closest in the line, which could be hardware, could be software, could be a supplier. So as a systems engineer, depending on the level or the size of system, and Rick had shown that tiers of specifications, sometimes you can be right in the middle, sometimes you can be up at the top of where those are, and then that depends on who you're going to work with at that stage. Your company may not work or may not develop that product themselves, and so you're working with a supplier, so you have a lot of different interfaces than that. But typically it's the next closest in line to that V or that cycle there that you'd be working with.
Anybody else have anything to add?
You talked about, you started with the program manager. And some of you guys are engineering management, studying engineering management or engineering management degrees. So that's a key one, is that program manager, system engineer interface, or that relationship. And so I'll say another thing you can do, people that are looking to kind of move into management quickly, is, there's also we have this certification, there's also a program management certificate PMI has. So I'll say it also kind of makes you stronger as a system engineering candidate if you're familiar with what the program manager is doing, just because then you understand where they're coming from, right, and what they want to do. And I'll say it's not uncommon for system engineers. I'm the manager of a system engineering group. Every so often, one of my senior system engineers moves into program management. That's that's a typical career path. So also understanding the program manager side of it is also helpful.
Does that answer your question?
Yeah, absolutely.
Okay. So another thing, there's a couple of things I thought of that related to what we were talking about earlier. If I was going to go for a PhD, when I went to figure out what my thesis was going to be, I would try to figure out what industries were hiring and what their problems were. And I would try to research that and make that my thesis. So now I'm kind of a resident expert at that particular piece, and you've got an industry to go to. So that's one way to do it. The other way to do it, when you get into a company, see if they have a rotational program. Okay? Those are the people that are the most successful because they learn everything about each piece of the company a little bit at a time, and when they're done, they get to, apply to different areas that they think they would like. And the people that are on the fast track are the people that know all about all the different pieces of the company, and they make, further up the corporate ladder, so to speak. So those are things to consider when you're getting a job. But make sure you listen and learn from the people that have been doing it for a long time. And if you have something innovative to bring up, don't be bashful. Bring it up and see if they like it.
And Wes has probably brought this up. You were saying, what's happening in the industry. Model-based systems engineering is a big thing in the system engineering community, and a lot of companies are struggling to make the transition from kind of the paper-based system engineering process where you have lots of requirements, documents, and so forth, to the model-based system engineering paradigm. So being an expert in model-based system engineering, there's having some skills at with the tools could also help you in a company that's trying to make that transition. They could see you as an asset in that area as well.
So I don't want you to all be overwhelmed as well, because we know you don't know a lot of these things. So when we hire you, we fully expect to be doing a lot of on-the-job training with every single one of you. So that list that Rick had put up there that said sort of the main categories of what we do as a systems engineer in starting with the analysis and doing the requirements and stepping down through validation and verification, you will take an awful lot of time to get through all of those and to really understand them. You could be on one program and have the fortune to have done from soup to nuts all of those things in order, and then go on to something else. But each project, each program comes with its own set of nuances. So even though you've done one of those phases on a contract, you will learn something completely different on another one. So it does take time to develop those, to hone in on those skills. And don't expect in a year to 2 years that you'll have all of those overnight. You'll have a good understanding of them, but maybe not the depth just yet.
Right. The basic premise is easy to understand, but seeing how different companies and even sometimes different departments or different individuals implement those is a little bit different. And when you've seen it 2 or 3 times, then you can take the best practices that you think from them and implement them yourself or suggest them. Next question.
So,
Could you state your name and everything? We should probably
Sure.
get that too. And wait till I get the microphone. What was your name?
Marcel.
Marcel. Okay, so he was the first question. The second question?
So my name is Juan Carlos Martinez, and my question, I'm a first year PhD student in systems. And I guess my question is more related to academia, so I guess it's more targeted for Professor Silva and Professor George. So I could go on and on and talk about what the fundamental challenges are for my specific application and my research that's related to systems, but I wonder what are some of the fundamental challenges on a scientific level that systems engineering has?
That's a good one. We'll wait for the microphone.
Who wants to take this first?
Should I go first or should I
Yeah, go ahead.
Okay.
Well, first of all, I guess you asked specifically about systems engineering, right? Not necessarily systems science. So I guess there's challenges really at all those levels, all those tasks that were on that slide, right? There's challenges in modeling requirements and understanding what is the best way of capturing those requirements and modeling dependencies between requirements. And there's a lot of work right now going on in change propagation, for instance. You have a change in a hierarchy of components or a hierarchy of requirements, how that change propagates through that hierarchy. So that's trivial to do if you have 10 requirements or 10 components, but if you have the F-35 and you have 1 million or 1 billion components, I have no idea if that number is correct.
It's probably classified.
Very low.
Then you have a network essentially with 1 billion nodes. If something happens to one node, you have no computational power to figure out what's going on, right? So what do you do? There's challenges, of course, in systems architecture, which is what I do. There's lots of them. How to deal with ambiguity, for instance. So there's mathematical ways that people have figured out to deal with needs that are fuzzy, things like fuzzy sets and things like that. That have limitations. How do we improve that? How do we merge it with probabilistic approaches? There's a lot of work in optimization, of course, and that has to do with how to, not really algorithms. Algorithms are left for OR and things like that, or computer science sometimes, but mostly in the formulations. So how do you decide the formulation for your problem? What is the objective function? Is it just an overall problem, or do you have nested optimization problems, one per discipline? How do those different problems exchange information with each other? There's a lot of work, obviously, also right now in data mining and machine learning. One of my projects that I really like right now is we developed this cognitive assistant, so like Siri, for instance, to help system architects with really architecting a constellation of satellites. So there's a lot of opportunities there, all of these technologies that are appearing, and people want to know what we can do to improve systems engineering with them. Do you want to add anything else?
I think Dani covered very well. I just say one more thing. This systems of systems is very important because there are many things that we think of as large systems, but they have to work with other large systems, and figuring out just conceptually how to deal with those, how to optimize something like that, how to make sure that the things keep talking to each other under various stresses and things like that. That's a very current thing as well.
There was an interesting paper at the last symposium about complexity, and there was Sarah Sheard is a pretty popular writer in system engineering. She gave a paper about a project she did for the Federal Aviation Administration, and they have issues now. You know, the aerospace manufacturers can build airplanes that are so complex that they can't. You know, the FAA, you have to prove that the system is safe to fly, and they say that the amount of labor involved in proving all the test cases in order for the FAA to say, yes, this thing is safe, they don't have enough, the FAA doesn't have enough time or money or manpower to prove that. So how do they decide what level of complexity? Is the system too complex? Yes, they can build it, but the FAA can't sign off on it as safe. What do they do? What do they do with that issue?
So let me
I
just
think it
add.
involves a coin.
Yeah. Let me just add that obviously these are just like a few topics, and there's so many, right?
Right,
So
right.
Rick mentioned the Systems Engineering Journal. So if you really want to know what's going on, just go to that journal, you know, their
Right.
current issue and a few past issues, and you can get a much better idea than us trying to
Yeah,
come
what are the
up.
hot topics?
Yeah.
Right.
It's interesting though, just because I'm very industry focused, and that's where I live, and I see my problems from my customers and what we're developing, and I was nodding my head and resonating with just every single one of the examples that he was saying of what's important, what's interesting to be looking at, and trying to help us solve these problems. You are doing what it is.
Did that answer your question?
Yes.
Okay. Next question.
I have
Hold
a
on, hold on.
My question is, Professor Daniel just already mentioned you are using data mining or machine learning for the architecture consulting.
Mhm.
So from the industry perspective, what's this very hot topic, data science, will influence systems engineering? It's a different discipline, or it is a discipline can be integrated into the system engineering?
So is the data mining, is it?
Data science.
Pardon?
Data science.
Data science, yeah.
Data
Data
science.
So
Information science and the ability to manage all of the information that we've gotten, come up with reasonable recommendations, something like that.
Yeah.
And the question is for industry or for us?
From the industry
Yeah.
perspective.
So what you're saying is, are we using data science for to help support system engineering? So I'll say for the most part at my company, there's a lot of machine learning work going on, but it's more like target classification type things. We're not really working on trying to modify what we're doing from a system engineering standpoint. It's more like algorithm. I'll say it's more like a sort of on the software algorithm side that we're doing machine learning.
And I would say I also see it in our hardware and manufacturing side. There's a focus on it. I actually was at a dinner here earlier this week with students, and one of them was from the information science department, so we got into talking about it. And I had to think about how that degree or the work that happens there, how it relates to systems engineering, kind of on the spot to say, well, would this person be applicable for a job with me, and where would it be? And because it's a very highly specialized skill, I'd say it's harder for us to have that as, say, a permanent need. And we actually have a separate organization that focuses on our information technology and our infrastructure, our enterprise systems, and a lot of where that happens. So I would see it kind of a little bit better fit there. But from the data mining perspective, so the examples that I gave her was when we're doing tests, this system of systems, there's so much more information. We have the ability to save and to store just about everything. And then it's, okay, great, now what do I do with it? Right.
Yeah,
So
right.
I have a lot of engineers who are trying to come up with really smart ways to decompose the data, to slice and dice the information so that it's meaningful to somebody else. Understanding how to leverage that data, metrics, what's important out of it. So we do it as kind of a normal course of the systems engineer or systems test responsibility, but not necessarily as a specialization. So maybe that's a gap for us, but definitely as a business, it's hard to continue to pay somebody to do that when it's a special need only on occasion.
So if I can just throw in a couple cents here. For when the data is input to the system, right, into whatever database you probably have multiple databases that need to somehow relate to each other. The problem is once the data is input and it's tagged, right? How do you know what tags to put on it, right? And then when you need the data to be tagged differently, it's too late, or you have to go back and spend a lot of money to retag it. So I equate this to, have you ever heard of design of experiments? Right? So the key premise of design of experiments is to think about the data that you're going to get from the experiment. What are you going to do with it? Okay? So pretend, use just data you've made up in your head. What you're going to need to put in your analysis, okay, and do your computations. Because if you wait until after you've gone through an expensive experiment, it could have taken 3 months to get the information, and you think, oh, it's pretty trivial, I'm just going to run it through this, my math model here, and I'll come out with an answer. You might find out, oh, geez, I really should have been collecting this data, right? And now I've got to run the thing all over again. So when you're doing data mining, the thing is to think, what can you do with the data first, okay? How are you going to analyze it? Make up your false data. See, what you're going to need to really make it right, and then figure out how to tag that data and what databases to put it into and how to relate it. So that I think is the key to doing data mining. And the problem is we've got a lot of data collected and none of that's been thought up front. But now, we shouldn't be doing the same thing over and over again and expecting a different result, because we all know that's the definition of insanity.
Let me just add to that one of the things is, what customer requirement are you trying to meet in a better way that needs the data? So that's you have to. So you don't want to collect data just because you can. Because now in the modern world we can collect data on almost anything, but you want to have some idea of how you're going to use it from a systems point of view to have the system work better.
Next question. Oh, hold on. I can't believe we remember.
We'll do the relay system.
Hi, I'm Vernon, first year PhD student at Cornell. I was wondering, just for anyone in the panel, what skills do you think systems engineers have that other engineers don't?
I answered that.
So maybe go with it.
Go ahead, Mary.
You need a big picture and the skill to be able to put it together out of little parts, and not just be focused on one thing. To me, it's simple, but
Yeah, I think
maybe
one
that's
of them is the
oversimple.
big picture, right? I think the other one is the idea of systems thinking. I'm sure you guys have probably studied that, right? Not everybody kind of approaches problems with systems thinking. So I think having done some work and thinking about that. I know at SRC, I'll say systems engineering is a recent, we recently discovered it. And one of the cool things is when people in like the software or the hardware groups go, you know what? Everybody needs to think like a systems engineer. Everybody needs to think, whatever you're building, everybody needs to say, hey, what are my requirements? How am I going to test it? Those sorts of things. So just approaching problems from that perspective is very useful.
But systems engineering is really, in my mind, equated to leadership, right? You have to be the one, and you have to be very disciplined, right? You have to be methodical, which is scientific, all right? And you have to be willing to go the extra mile to do things, a certain way. And that's not saying you can't cut a corner once in a while, but you have to know when to cut those corners. You have to, and that takes experience. So you start out doing it, and you see, you start doing everything by the book, and then you see whatever particular business you're in, or what particular project you're on. If you're going to do similar projects, you can see what benefits you're getting from certain methodologies, and you can capitalize on the ones that have been strong for you and not worry too much about the other ones. But like we've multiple of us up here have said, system engineering can be in anything, and people should think like a system engineer, but a system engineer should be the one that's leading the project to tell them what needs to get done and how. Okay, how to break a project up into little pieces, get a work breakdown structure, get those estimated, get those all planned out, get them into an integrated master schedule. All that stuff really, and you work with that. You'd be working with the project manager or the project engineer on that, right? But you have to help make sure that everything comes together cohesively and nothing is being left out. Okay, that's your main job. And if you can think like that, if you think again in big picture, and you have leadership capabilities, and you have discipline, okay, you want to do things methodically, those are the traits I would look for in a true systems engineer. Did that answer your question?
Yes.
Okay. And who would like to ask the next question? Or does anybody have anything to add? Okay.
I just want to put kind of an anecdotal on for 1 second. Sorry. I'm going to talk to you after because I want to update your slides. We are actually probably, I don't know what the last 10 years or however many years it's been. Have you guys heard of the term Agile? Right, so Agile methodology kind of was born out of a software development cycle, and everything that we showed you on the slides here talked very traditionally about this waterfall approach. If I'm going down the V and I do this, then this, then this, then this, and all the way up again. With Agile, now you're looking at how do I break down my system so I can build it up incrementally. I can see earlier on in the development of my product how it's going to work, how well it's going to work, kind of work out some of those kinks earlier on in that life cycle. It's also better from a customer engagement standpoint of being able to have them see, touch, and feel whatever it is that you're designing. And if they have those course corrections, because we mentioned before, you throw something out at them, they're going to be like, oh, now I know I don't want that. You can do that a lot earlier. And the thing with Agile and Agile teams is that idea of having somebody who understands that. First, somebody who can break it down into those pieces to know what I should build first, what's the right component earlier on, and then how to build on that. And then managing that work scope, managing that effort, both on a systems and a software, maybe even hardware development cycle. And that is an incredibly challenging role, and it's definitely something that we're still growing in our business to see who has those capabilities. It breaks down a lot of barriers too, because it puts at the heart the team working together as truly a team as opposed to a hierarchy, and everybody having an accountability getting something done. But at the same time, there's still a product owner, somebody who has to be responsible for figuring out how to break it down into those pieces. So that's just another thing to go look up and see what Agile's all about and how that fits in, because we're trying to get it away from it being a software thing and truly a systems design and development thing.
INCOSE has an Agile systems engineering group led by Rick Dove, who is going to be speaking in October at that conference at
Great Lakes?
Rochester, or when you can't pronounce.
Worcester Pond. WPI, Worcester,
I can't even
Massachusetts.
That's the Great Lakes Regional Conference I had up on the screen.
Right, that's coming up in October. You should go, Mary.
Okay.
So, interestingly about Agile, it has some very positive effects. And a lot of companies are going to it. For me, it's like what we used to do 30 years ago. It's basically a group of very knowledgeable people writing things down on napkins and Post-it notes and being able to, do things, and they're the heroes. And then eventually what happens is those heroes die off or they move, they whatever, right? And they're gone, and now the company's left with, what do I do now? Okay? So Agile is trying to take that hero mentality and put it together more formally so we don't lose that information. All right, and it takes it takes less discipline, but you still have to make sure that we don't go full circle where people are doing Agile and then things are getting lost and they go back to a more traditional way of documenting things. So you need to take the best of both worlds out of Agile and Waterfall, combine them, and then you'll have something, right? Because I don't think Agile on its own is ever going to stand up unless it morphs into something that allows you to get the documentation you need
you have to
before.
document.
But the greatest thing about Agile, and Mary touched on it, is you're really constantly in contact with the customer. Okay? And not all customers have that kind of time. So you can't always use Agile. But you can use various forms, and you can mix and match. Okay.
Next question.
Yeah. Oh, so we had a question here.
My name is Philip Perret. I'm a first year PhD student. I have many questions, but one of them is like, I'm thinking about my PhD as a system, so I have to convert my needs into my goals, I guess. I'm not sure about my needs, so one of the decisions I have to make is which classes to take. So what's, in your opinion, the skills that an engineer should have, apart from the social skills and engineering skills? Should I be taking classes in accounting and finance, for example, or is it more important game theory? Or, if you could give some feedback on that.
What do you want to be when you
grow up?
Now when you grow up? I'm still asking that question. What do you want to start? Do you want to go and be a professor, or do you want to go into industry?
Okay.
Yes?
I've been working in the space industry, so I want to go back to space.
Okay.
Those things, satellites and things like that. But I guess it depends on how do you see the profession going in the future, and which course do you think are going to be required in 10 years or so.
I was going to say, I think you touched on one of the real challenges of systems engineering is that it's so broad. I'll be honest, I really struggle myself with what parts do I need to learn next, right? And so I think some of the key to that, like you were saying, you're going to go into space, is sort of, like I said before, what industry are you interested in? Because I think each industry has its own challenges. And so, some of the industries are just embracing system engineering. I know there's a lot of work in the healthcare field of people trying to help the healthcare people by bringing systems thinking and systems engineering. So some people, they're just trying to learn the basics, but there's other ones like, say, the aerospace, where maybe complexity and system of systems are some of the key issues. So some of it is industry driven. But I think also the blessing of it being so broad, you can maybe follow your passion. Maybe you can develop your niche or develop your deep expertise in the things that you're excited about.
Go ahead.
You're going to follow on. I have something a little slightly different.
Okay.
So go ahead.
I was just going to add to that from an industry perspective too. Some industries are more process intensive from a quality and a rigor in terms of meeting those CMMI standards, and also from a safety critical or just a hazard perspective of what do you need to do. So there may be some things like Lean Six Sigma that would be applicable. It's not in all industries, and it's not in all aspects of systems engineering. So that's another thing back on which industry you're in.
Actually, that was leading into what I was going to say. The industries vary a lot, and we have here people who are from industries that primarily work with the government and the military. There are many, many companies that don't fit in that category, and a lot of them were the ones who came to Cornell and asked us to start this program here because they wanted to see people coming out who could also think about how to introduce this into industries that didn't have this tradition, and the government telling you pretty much what you have to do. Not exactly how you have to do it, but pretty much what you have to do. So a lot of you may get jobs in industries that aren't that developed in systems engineering, and you may get the job via your specialty from an undergraduate or a master's degree or something like that. And you'll be one of the people that who will help them help the company start to think in a systems point of view. So I've been involved with a number of commercial companies with that are in that various stages of that, and some of them are just beginning to think about it, and others, Cummins, for example, makes diesel engines. They're just converting their whole 10,000 engineers over to it. They're just starting that right now, and they're looking to tailor it to the what fits their particular company, their particular product. So there's a lot of tailoring going on. The other kind of tailoring is tailoring to smaller size companies. Smaller size companies need this also, but it was mentioned earlier, you can't use the full sort of Department of Defense kind of thing if you have a startup company with 15 people in it. You're not going to do it that way. But the principles apply exactly the same. The steps you want to go through and all that, they apply just as well, but you have to tailor it differently.
You know, that's a point I wanted to bring out. So, you know, with the small companies, like you said, you need to scale things down. I think another point along those lines is, especially those situations, you need to really focus on efficiency, and that's kind of part of what that agile process is, to try to get through it as quickly, the system engineering process, as quickly and efficiently as you can, because in some companies there is a fight between sort of the system engineers and what you call more the functional, the hardware and the software, because a lot of the hardware and software people, they don't want to wait for the requirements. They want to just build it right now. So sometimes, you know, a program or a company can have a bad experience where the system engineers spend all the money generating the requirements and polishing them and reviewing them and, you know, making them perfect, and all the money is gone. And the next project is not going to get a big system engineering budget, right? They're just going to throw it together as quick as they can. So doing the process well, but doing it as efficiently as possible can be very important in your company, especially if it's kind of a small or medium-sized one.
So the way to fix that, hold on a second. The way to fix that is to, if you don't remember anything else, remember these two words, buy-in, okay? So when you've got a team of system engineers and you've got a team of hardware, software, quality engineers, and the system engineers are off on their own doing their thing, and these guys are standing here twiddling their thumbs saying, come on, I need requirements, I need to start doing things. All right, get them involved so that you get their input, so that when the things that you hand down to them, they are invested in it. They're not going to just throw it away because they had nothing. It's a thing called not invented here, right? So if they have input to it, they're more likely to use it, and they're more likely to do it quickly. And what I would suggest, to answer your question, my master's was in systems engineering, and it was distance learning through Florida Institute of Technology. And my company chose since they were paying for it, they chose the classes that I had to take. You know, and everybody had to take the same class. It was a small group of us had to take the same class, one right after the other, step block. So some of those were tailored to our industry, but most of them were pretty basic, like system engineering management. You definitely would want to take that. Modeling and analysis, you'd want to take that. How to make hard decisions, you definitely want to take that. Requirements management, definitely. Those four things are, generic across all systems engineering. And then your other classes, you can tailor to either your interests or whatever industry. I thought you said you might be going into the space industry, so I would look at things that are relative to the space industry. And I wouldn't worry too much, about the finance end of it, like you had asked that question. It certainly helps to know something about finance, but if you get into the rotational program, or if you don't do that, if you can at least ask people in those departments what their job is like, it'll help you understand how every company's a little different, but there's a lot of similarities too. So it'll help you get a good understanding. But those basic four things, requirements management, system engineering management, decision analysis, how to make hard decisions, and modeling and analysis.
Can I just add a quick thing? Yes. It's a short story that I think it's relevant. Sorry, Wes. So about a year ago, Al and I, among other people, wrote a proposal to National Science Foundation to fund our new PhD in systems, and we were proposing a traineeship. They're called traineeships. So we spent a few weeks thinking about your exact question, what courses should systems people take? So we came up with an answer, and I thought that it would be worthwhile, since we thought about it, maybe you want to know the answer, right? So we thought that, and we called it something like, we need a new generation of engineers to confront global challenges or something like that. And we came up with network science, data science, systems engineering, of course, the 4 things that Rick mentioned. And then we added something that hasn't really been mentioned, but I think it's important. We also added an aspect of social science. So that traineeship had a requirement that every student enrolled in that program would have to take at least one course in the social sciences. And that would be something like sociology or psychology or something like that. And the reason is because if you think about complex systems, every system is a network, right? Every system has, especially now, we produce a lot of data, want to know what to do with the data. But in the end, systems engineering is about people, right? It's really about people. So I think you really want to have some background about, how people communicate and how people relate to each other in order to be successful.
That's a great suggestion, yeah. And written and oral skills are very important too, if you can do anything to help with that.
Yeah, that's a great point. At the SRC, I teach a class called Crucial Conversations, which is about conflict management. And I think that's actually, it's a great skill, like you said, for the systems engineer, has so many points of possible conflict, right? There's the program manager, there's the customer, right? If you're, Dani said, if you're allowed, or it talked about if you're allowed to talk to the customer, then there's all the hardware, software, functional quality, all those different groups are possible points of conflict. So being able to manage conflict well is useful, as like you were saying.
Or babysitting 101.
Go ahead.
Okay, just one question I had maybe for you guys to think about is TRLs, technological readiness levels, which I think might help people focus on what level of engineering they want to do.
That's right, yeah.
That's a good point.
You guys want to comment on that?
First of all, somebody explain the TRL.
Oh, yeah, I'll explain it. Okay. So technology readiness level, which some of you will get in 5100 or 61.
Poco.
Yeah, but basically the idea is that technologies come at different levels, from one being basic science that you think it should be able to do something useful in the future, to something that everybody knows how to do really well, like design a beam, and maybe even out of different materials. And there's all these stages in between. And some people would like to use sort of established technologies and put them together into systems. And other people say, we need a system that there is no technology for, and I'd want to get in early and figure out what the requirements and what kind of science we can be used to develop some kind of technology that might be useful. And you should look up TRL in Wikipedia or something, and it's probably in the handbook too, Systems Engineering Handbook. And you do want to think about where you like to operate, because actually at every level you need the systems engineering. If you're trying to take some science and put it into an application that's going to lead to something later, you can use systems engineering approach there just as well as you can. If you have a bunch of established things like building a building, let's say the traditional way, that's pretty well established, but you still absolutely need the systems engineering to put together a building that the customers are going to be happy with.
And it's going to lend itself to your methodology, like Agile lends itself really well to the lower TRLs and science methods, because people are more open to new science, or they can find new science and apply it without a lot of established rules. When you're doing a radio, let's face it, radios are, it's not a really low TRL, it's very high, so it's merely just an integration issue.
It depends on the radio.
You'd be surprised. There are some low TRL
Radio.
issues that come out that we've had to handle over the years. I've even gone to CERDEC, to where the TRL geniuses are, and tried to work with them to try and figure out what level that they're looking for. And the lower the level, the higher the risk. Okay, the more it's probably the most interesting. If you're more of a scientist type of person, you want to work at the lower levels. If you're more of an engineer type person, where you want to do something and see it done and be able to produce it, that'd be up at the higher levels. So that's a great suggestion.
I'll add a comment on that one too. There are definite industries that focus heavily, I'll call it research and development, which is generally your lower tier levels. There are industries where that's what they do. Their job is to come up with the next thing. We have a division called Skunk Works. MIT has Lincoln Labs. I mean, they actually are chartered or contracted by companies or governments or whomever to come up with those cool new things. Most companies have an element of research and development. I mean, it is how they continue to grow and to continue to get business, right? You can't just tell yourself, I'm going to do the same thing for the next 50 years and everybody's going to keep coming back to me. You've got competition. So you've got to stay ahead of it. You always have to be a little bit ahead of your competitors and say, well, what are they going to get into or not get into? You're also going to look at how is the market variability. And companies may vary from year to year or even within a year and say, I've got lots of money to invest now, and then I'm going to change that next year, and I really don't have the money to do that. So they look at, do I have a 3-year outlook or a 5-year outlook that I'm investing in? So my caution is not too much to look at, is that company the right one for me because I want to do all the research, because even that one company that says they do more of that research and development could change based on other impacts.
Just a quick comment. So I've been around for a long time and seen a lot of aerospace companies set up a research division that lasts usually about 5, maximum 10 years, and then they absorb all the scientists into the production, not the production, but the design end of things. And then about 10 years later, they say, gee, we ought to get a little more blue sky research going, and they start again. Now, the Skunk Works are probably an exception.
Yeah.
But a lot of companies started Skunk Works, copying the Lockheed Skunk Works, and then they have it for a while, and then it goes away.
So I'll give you another specific example that we've been going through. Lockheed's such a big company, we love to acquire things. And actually, we've made, a couple of years ago, we acquired, I can't think what they were actually called before, a small UAS, unmanned aerial systems company out in California, based out in California. And they were in the early stages of it. And Lockheed had said, hey, we want to get in on that market. You know, unmanned vehicles are the thing. Everybody's going to them. That's kind of a niche. We had a certain size of the vehicle. We wanted another size, so we bought this company. And because that company was needing to be bought for a reason. It was struggling, it had some challenges, it was not doing well with its customers, going to lose its contract. So a big company like Lockheed coming and investing is great. However, what it meant was all of the money that we had set aside for other research and development in other lines of business got it yanked away to go funnel into this one company and get it back and up and running. So things like that can happen too.
Right, yes.
Yeah, funding is a heartbreaker sometimes, and you have to learn early on that you really have to be good at presenting what the return on investment of whatever you're doing is going to benefit the company. Okay, so you can fight for that funding. So that's what you should learn early on. It's getting kind of late, so was there another question somewhere? Somebody have a question? I thought over here.
Hi, I'm Kristen Wilkins. I am an MN student here at Cornell, and thank you guys all for coming tonight. My question builds off of what Professor Salva was saying, how systems engineering is about people. What systems engineering tools really help you work with people? Like, where have you seen success?
Which ones don't?
Help me.
I can start and maybe you can jump in, but most of what I would call the core systems engineering tools that are taught, for instance, in the program that you're enrolled right now, are really meant to help communicate with people, right? SysML, it might seem like a boring thing that you're modeling boxes and stuff, but it's really to help you communicate with other teams, right? And to make sure that there's no confusions and to be formal with the level of communication, right? There's tools that if you take Sirietta's class, for instance, that are more on the human side of things, creativity, design thinking, all those things that help us structure a little bit the creative process to try to maximize the productivity. What else? help me here.
Basically, you have to you have a lot of people working on most systems, more than one, of course. And this is a way of making sure they really understand what you're expecting from them and what you can give them, especially the interfaces and also the requirements going interfaces going sideways, requirements going up and down, and it makes sure that if I walk in and tell you something, or even just write it in text, that can be interpreted many different ways. So this makes communication more precise, doing it in a systematic way.
So those are some great examples of communication within the work product itself that you're developing, and if you can effectively transfer it from one phase to another or one team to another, that's brilliant. The other part of it is truly that person-to-person contact, and there's an art, and I don't have it, and I'm working on it, to getting people to do what you want. And also just to do, to get stuff done. And there's just some amazing techniques for how to get people to be effective and work well in that team. You guys have probably all been through a project at one point or another where you had somebody who just didn't care. And you were pulling all of the weight. And you're like, you know what, I just have to get it done because I need the grade at the end of the semester, so I'm just going to do it. Generally, in the workforce, we don't want to operate that way. We want that person to pull their weight. So how do you get them to, or how do you communicate with another leader or manager to get them more on board or off your program?
Are you taking project management this term?
I took it last semester.
Okay, so that's a lot of those things are in there.
Yeah, no, but that was really the core of my question, what we were just elaborating on.
Yeah, yeah.
So-
It does come down to people in your team too, and you're not always going to get the best team, and just sometimes just have to grin and bear it and work through it and go, hey, can I have a different project next time? Get off that one.
Try to incentivize people to figure out what makes them tick. Okay, what would, if they did something, what would, tell them what they would get out of it. Try to help incentivize them. And also, if you want people to do things and they're not very willing, try to make it think it's their idea. Make them think it's their idea. That's the biggest key, right? That, and then also the buy-in picture. If they have input to it, they're generally going to be okay with it.
So there's a quote from Eisenhower that you can accomplish almost anything if you don't mind who gets the credit. So make sure you give people the credit.
That's right.
And that they know they get the credit, even if it was your idea. Make it seem like their idea.
You'll alienate people if you take credit for work that they've done. So make sure you always give credit where credit's due. Any more questions? You're all patiently waiting for the scholarships, right? Well, I'd like to thank the panel for coming tonight. They did a great job. I think they answered your questions pretty well. So I'm going to ask three of the panel members. I won't ask Kevin because he's our president. I'll ask the three panel members here to pick a name, and you'll get a $150 scholarship from the Finger Lakes chapter of INCOSE. We'll start with Al. Okay. One. Suspense is killing me.
She folded that name.
All right, so Al, why don't you read off your name? The name of the code?
J1 Jean.
I see.
Probably didn't pronounce it well.
You want a second?
Fox, right?
Oh, yeah.
That's your name, right?
Yeah.
Okay.
Okay, Amy Tavzel.
Amy.
Amy, yeah.
And Juan Martinez.
Juan. So with that, I'll close everything down and say thank you all for coming. It was a pleasure meeting all of you. If you have any questions, you have my email address. If you have a question for someone on the panel, I can put you in contact with them as well. And feel free to ask me anything you like. Okay, we're happy to help you guys get going. We want to see a bigger system engineering presence in the world, and hopefully this is our way of helping that happen. All right, so thank you again for coming, and have a safe trip home from those from you from Syracuse. and have a safe walk back to your your dorms from people from Cornell. Thanks again.
Thank you.